Alright, let's do some physics. This is a very riveting, exciting problem about a rather large man who's running, and we're going to try and figure out exactly what's happening to him in terms of his motion. So, a rather large man is running. Let's call him, I don't know, Szymanski. He runs, giant quotes on that one, up a hill. He is experiencing a constant acceleration of negative 0.003 meters per second squared. The hill is a 1,200 meter trek. How much time will it take him to get from the 700 to the 800 meter mark if his velocity at 0 meters mark was 2.2 meters per second? All right, so first things first is trying to get our thoughts down on paper. So let's start with drawing some stuff. So let's see if I got the right pens picked out here. Sure, that works with that. So I'm going to list my givens. So my acceleration is a negative 0.003 meters per second squared. Let's go one size smaller. My time interval is what I'm looking for. And then I know my initial velocity is 2.2 meters per second. And then it gives me two different spots I'm looking at, which is kind of weird. I got 700 meters, and then I've got 800 meters. And it says the whole trek is 1,200 meters, but I don't think I need to know that. I think that's just extraneous information. So I'm going to draw a little picture about what's going on here. So it looks like we're trying to get to the 800 meter mark. And there's the 700 meter mark, and I know at this point my initial velocity is 2.2 meters per second. So when I draw this out, I'm trying to find the time interval for this section here. So when I draw this out, it seems like I might need to do two separate displacements. Alright, well I like to draw a velocity time graph just to be super certain of this. So there's my velocity time. And apparently he's slowing down as he climbs the hill. Initial is 2.2. And then I have no idea what this time is. But I know that somewhere in here, I'm going to cover 100 meters. And so somewhere in there, that area is 100 meters. So I don't know what this point is, and I don't know what that point is. So maybe it'd be nice to know those velocities. Those are two separate velocities. It might be nice to know. But I do know that the slope is negative 0.003 meters per second squared. So this is kind of all the stuff I know. So based on this, it seems like I'm going to take a first stab at this by doing some displacement calculations. All right, so that's what I'm going to do right now. I really don't kind of need the problem entirely, so I'm going to start doing some displacement calculations here. So I think I'm going to be using this equation of my displacement is equal to my initial velocity times time plus 1/2 my acceleration times my time squared. And I feel like I need to do this twice because the first time, I know the initial velocity has to do with at 0 meters. So I want to find this to this. So I'm going to have to find the whole way down, and then I'm going to do some subtraction. Same thing here. I could do the whole area here and then find this area and do some subtraction. So either way seems to kind of be pointing at I got to do two equations here to get my answer. So let's take the larger one here. So we've got 800 meters. My initial velocity is 2.2. I do not know the time. Plus 1/2 times negative 0.003 times t squared. Oh, look, it's a quadratic. Now, whatever you got to do to your quadratics, that's your quadratics. You know, opposite to b plus or minus b squared minus 4ac all over 2a, or plot on a graph, or use your calculator. I've got a solver in my calculator that lets me solve it, so I highly recommend you doing that. You'll get two answers, so I get t equals 800 seconds, or t equals 666.6 repeating seconds. That's interesting. There's two possible times. Okay, well, let's see what that is. Interesting. Now, the other one is I have to do a displacement then, again, but this one's going to be 700 meters. And so my initial velocity is, again, what I'm looking at. So same problem, same equation. 1/2 a delta t squared. And then start subbing and solving. So 1/2 negative 0.03 times squared. Again, quadratic, whatever method you got to do it. But now I get t equals, let's see, what do I get here? 1,000 seconds, or t equals 466.6 seconds. So again, I have two answers, and it's not like I can immediately get rid of one because they're both positive. It's not like you have the imaginary number or the negative time. These are both positive times. So I got to kind of figure out what is the matching pair for these two. And if you think about it, if you're going along and you're going along this ramp, eventually the object, since we're just using math, would eventually hit here and it would start to slow down and then speed up in the opposite direction. So if you're thinking about going up a hill, eventually you might run out of gas and then start going back down the hill. And so that might make sense why we have two separate time intervals to be at the same location. But we have to figure out, well, where are the right ones? So as I'm running up the hill, my time will increase. So it should go the bigger number with the, wait, that's smaller. So it can't be these two. So these are not making sense because that's on the way back down the hill, because the 800 would be, say, up here, and then the 1,000 would be down even further. So it looks like this goes up for a while, and then it ends up coming back down, and that's where these two numbers are coming from. These two, on the other hand, because this is my 700 and this is my 800, it seems like at the 800 it is 666.6 seconds, and this is 466.6 seconds. But then, like I said, on the way back down, it seems like this is 1,000 seconds and this is 800 seconds. So that makes sense. But I'm looking for the way up. I'm assuming that this rather large man running doesn't pass out and then roll back down the hill. That would be awkward. So we're just not going to concern ourselves with that stuff. All right, so these are the two that we're looking for. So these are our two times. So now that we have that time, we want to know how much time will it take to get between these 2 points. So we have the time at each of those locations, so now we just need to do some basic subtraction. So our change in time is equal to, your second time. All right, so it's basically your change in time. So you have 666.6 repeating minus 466.6 repeating, so that equals 200 seconds. So it takes our guy 200 seconds to get from the 700 meter mark to the 800 meter mark. So this change in time right here is 200 seconds. So that's one way to solve the problem. I hate to break it to you, but there's others. So let's say that didn't make sense to you, that you didn't get that at first glance. You might have realized, hey, I need to know these velocities. So what's that velocity and what's that velocity? All right, so I'm going to do a second solution, and I'm going to do it in a slightly different color now. Let's go, I don't know, red. Let's go red. All right, so I'm going to use the same information, except I'm going to use it in a slightly different way. All right, so I'm going to rewrite my information. So I was given my initial velocity is 2.2, acceleration is negative 0.003, and then I'm looking for these displacements. All right, so 700 meters, 800 meters. But this time I've realized that when I looked at my velocity time graph, I felt, it'd be nice if I knew what is this velocity and what was this velocity. Maybe my brain said, if I knew those, I bet I could solve, because that could help me out. So let's say I take that path. Well, if I do that path, then the equation that's going to help me solve for my final velocities is actually going to be my v squared equation. So it's this equation, and I'll be using it twice. So the first time is to find my velocity for one displacement, then for the other. So I go v squared equals 2.2, this should be squared, plus 2 times my acceleration times my displacement, which I know that number. I don't need to write that down, so I know the number. My first displacement is, or my bigger displacement, I should say, is 800. All right, so now I can solve for what my velocity is. And again, you'll actually have a positive and a negative here because you're taking the square roots, but we're just going forward, so we only care about the positive. And if I do that, then I get a velocity of 0.2 meters per second. All right? Then I can do it again for the other displacement. That should be an equal sign. Plus 2a delta x. So then substitute everything I know. $700. Solve for this. You'll find you have a velocity of 8.8 meters per second. So as you up the hill, obviously got slower. So at the 800 meter mark, you had only a 0.2. At the 700 mark, you had the 0.8. And then you could solve it from here, you could solve it for two different ways. You could say, hey, I look at the graph and I think of area. So I could solve it using area. So I could say that the delta x is my area. And that is basically a trapezoid. So I can use my displacement equals 1/2 v plus initial times delta t. I could use that equation. And then I could say, well, the displacement was only 100. And then 1/2. And then my final velocity, we would say, is the 0.2. I should erase that, be a little prettier, neater here. 0.2. Da-da-da-doo. And then plus my initial velocity, which was 0.8. And then my time is what I'm looking for here. So if I do this math, then I can figure out that my time is, again, 200 seconds, which is the exact same way I got when I solved it there. But let's say, like, hey, I didn't want to use area. I wanted to use more math. I love math. It makes me excited. Good days with math. Well, then you could also have chosen a different equation. You could have said, I'm going to use my final velocity equals my initial velocity plus my acceleration times my time interval. And then you say, well, my final velocity was 0.8. My initial velocity was 0.2. My acceleration was negative 0.003. Solve for my time. And then if you do that math, you get 200 seconds. So again, all of these answers all gave the exact same answer of 200 seconds. So they all totally agree. And this is why when we say in physics, like, hey, I can't tell you the answer because there are multiple ways to solve every problem. And so you have to kind of figure out what path you want to go to. You can go pure numbers, pure area, pure graphs, things like that. So there's a multitude of ways to solve every single problem. And so I highly recommend that you figure out kind of what works with you and figure out the tools that you need to be successful. Because it's really hard for us as teachers to say, well, this is how you solve this problem. All right, we like to show how to solve every problem, all the different types of ways. All right, so that's how you can solve these fun problems. The one thing we'll bring up is that you notice that in all these equations, I always made sure my equations matched. So, for example, when looking here, I used 800 instead of 100. A lot of students say, oh, well, wasn't your displacement 100? That's true, but that would mean I would need to know my velocity at that location, and I would need to know my velocity at this location. All right, so if I'm using my initial velocity, I'd have to know the initial velocity that goes with that displacement. And since I had the initial velocity way here at 0, that's not going to be able to be compatible. So make sure that you're not mixing and matching numbers. And that's why drawing graphs and drawing number lines is very important to making sure all this stuff agrees. So I hope you had as much fun as I did. Bye-bye.